All right, in this video, we're going to work the following problem from our book 4.20. It says, as reported by the Federal Bureau of Investigation in Crime in the United States, the age distribution of murder victims between 20 and 59 years old is as shown in the following table. A murder case in which the person murdered was between 20 and 59 years old is selected at random. Find the probability that the murder victim was A, between 40 and 44 years old, inclusive, at least 25 years old, that is 25 years old or older, and C, between 45 and 59 years older, inclusive, and then under 30 or over 54. Okay, so here we're given the frequency, right, the counts, right, the frequency distribution. To calculate the probability of these events that they're asking for down here, we are going to have to know how many items or cases are in our sample space. Okay, so in order to do that, we're going to have to add up all of these numbers right here. So I've already done that to save a little time, and so here you can see that that's not quite right. I can see that first number is off, right? It should be 2329. Let me just, yeah, 9608. That looks good. Okay, so so we added all of these up and we get 9608, right? And so that is the number of cases that are in our sample space. And so all of these answers, right, they're going to be fractions with this number on the bottom. So, all right, so first off is, what is the probability that the case selected at random involves where the victim is between 40 and 44 years old? That, if looking at these categories right here, that's just this one right here, 40 to 44. So that's 900 cases. So that would be the number of cases in our event, and then we want to divide that by the number of cases in the sample space, which is 9608. All right, so I'm just going to leave these as a fraction. You can, just divide this out and convert it to a decimal if you like. All right, part B says, find the probability that the murder victim was at least 25 years old. Okay, that is 25 years or older. So at least 25, we're talking 25, right, or all the way down to here. Okay, so that's a lot of stuff to add up, right? We're going to have to add all of these numbers up, right, and then put that on the top of here, and then put 9608 on the bottom. The thing is, though, is that there is a shortcut in the sense that it's just going to be easier calculation-wise. We know the total, and all we need to do is to subtract off of these cases. These are the only cases, right, that don't fit the description of the event. So on the top, we'll have 9608 minus 2329. That's just a little easier to do that way. That way we just have to do one subtraction instead of a bunch of additions right there. All right, so that's going to be 9608 minus 2329. All right, so I get 7279 on the top and 9608 on the bottom. All right, part C, it says, what is the probability that the victim is between 45 and 59 years old inclusive? So 45 and 59, right? And the inclusive just means including the ages of 45 and 59. All right, so that's those three right here. All right, and so we're going to have to add up these numbers right here, and that will be the number of cases that are in the event that we are thinking about here. All right, so add those up. 854 plus 673 plus 500. That comes out to be 2027. All right, so that is the probability for part C. All right, so for part B, right, they want to know what is the probability that the randomly selected case involves a victim who is under 30 or over 54. Okay, so that's going to include under 30. That would include these two, right? And then over 54 would include this one right here. So we're going to have to add up these numbers here and add this number to it, right? And that would give us the number of cases that are in that event. All right, so let's do that. So 2329 plus 1892 plus 500. That gives us 4721. All right, and that would be the answer for part D.